Welcome. This is the Aspiring Astronauts Conference, and you are at the live broadcast of the International Organization of Aspiring Astronauts. We will now have a waiting period until the presentations begin. Would you like to be teleported to the International Space Station and admire Earth orbit in the meantime? If so, type yes in the chat. Roger that, but first, don't forget to grab your popcorn, sit in the most comfortable spot in your house, and call your family to watch. Activating teleportation. Destination, International Space Station.
minus 15 seconds. Guidance is internal. 12, 11, 10, 9. Ignition sequence start. 6, 5, 4, 3, 2, 1, 0. All engine running. Liftoff. We have a liftoff. 32 minutes past the hour. Liftoff on Apollo 11.
Hi everyone, my name is Mulry. I'm the co-founder of the International Organization of Aspiring Astronauts, or IOAA, along with João, Pedro, Cosso. And welcome to the first day of the Aspiring Astronauts Conference. Thank you to our media partner Infinoscope and to Space Magica, who's organizing this conference with us. For our presentation today, I'm going to talk about how IOAA started and why it's important to have a community of astronauts from all over the world. And then João Pedro will talk about the importance of international relations for the future of space exploration, and we'll also announce our newest IOAA project. Then we will have presentations from Pravin, Wakode, and Asaraf, Shaikh, who are the co-founders of Space Magica, as well as Sandali, Kumarasinghe, and Sophia, Knowles, two of our members who have very interesting topics for you all. IOAA started with an Instagram last year in January of 2020. The reason this came about was I, as part of an organization called Back to Space, had met a lot of people from around the world. I had been running their social media account for the Back to Space ambassadors and had gotten to meet a lot of the different Apollo astronauts. Throughout this process of being part of Back to Space, I met so many other incredible individuals who shared a dream of becoming an astronaut. I realized that for one, it wasn't just me who had this dream, but also that I had a lot of fun meeting other incredible people who wanted to go to space and found myself less scared of having to compete with them. I had always thought of the astronaut field as something where I would have to fight really hard and work and just be better than everybody else, something really competitive and kind of cutthroat. But as I started to meet people who were involved in this, I realized how much fun it could be to interact with people who shared my dream and how exciting it would be to build that network. I started to realize how truly collaborative space is and how we as aspiring astronauts can start to build that collaboration right here and right now so that one day we can work together really well on crews and go to the moon and Mars and beyond. I started to think of this idea and wondered, like, how cool would it be if we had an organization where everybody who I know and other people that we find who want to be astronauts could meet each other and network and start to build those friendships and those bonds to where we could one day have these really successful, really awesome teams. As I was thinking about this, I got a DM on Instagram one day from João Pedro, and it went to my unmarked DMs at first, like the extra ones that go off to the side that you don't really see. So I checked one day and I realized, wait, this is the same idea. He had approached me with the exact same idea that I had had, only instead of just focusing on the US, which is where I was from, which is where I was going to focus, João Pedro wanted to talk to the whole world. That's kind of a big goal, kind of a big dream, and really excited me and inspired me and kind of scared me a little bit too. We got to work and started building our organization. We talked about ideas, we built an Instagram, we made a website, and we really just fleshed out this idea of having a community online where people who probably won't meet in person for a very long time, but who are inspired by the same dream of one day going to space, can meet each other and become friends, can share opportunities and interests, and can work together to further all of our dream. I have grown a lot personally through the collaboration of others, through my peers giving me advice, telling me about programs to apply for, about different internship opportunities and different summer program opportunities to look into, especially when I was in high school. That was really big. I got to be involved with some different NASA programs because of the recommendations of some of my friends. So I wanted to be able to do that for other people as well as gain some of those insights as well, because we have this knowledge, we have this idea of what it takes to be an astronaut, or what are some things you can do to get closer to that goal. And of course we want to share them, and everybody comes up with different ideas, has different knowledge of different programs from around the world. And so by bringing all of these people together to share opportunities, we're all able to do so much more and to really maximize our time as students, as professionals, and become more aware of what we need to do to explore this field of space science and human spaceflight. It's very exciting and a big goal, of course, to talk to people around the whole world, but I found it very exciting to get started on. So we messaged people on Instagram, and as we were brand new, it was just a lot of sending DMs like, hey, we're starting this organization, you want to be an astronaut, we want to be astronauts, like let's all talk, let's all meet, and then maybe we can be astronauts together, which sounds kind of like a naive goal, but we were shocked at the response. People kept following us and started being featured on our site. We moved from our original forum on our website once that was not really working out super well and was kind of small. We moved to Discord and then now have active conversations with our members most days. We started to explore different ideas such as IOAA Academy, which is an online teaching thing. Different members can record videos about things that they know a lot about, such as Russian or programming, upload it, and then other members can watch and learn. We have some other things such as a book club that we started over the summer. One of our members, Lauren Daniels, started that. And that was honestly one of the coolest things about IOAA so far, because we could all jump on a call from all over the world in all different time zones and read a book together and talk about our experiences of wanting to be astronauts, which despite our time zone differences, our language barriers in some extent, our geographic differences, like we were able to connect over the fact that we all shared this dream. And we're really able to support each other in our hobbies and our goals and our interests and in our drive to go to space. I think one of the most exciting parts about IOAA is just how encouraging everybody is. I've never felt that as part of IOAA. I'm in competition with these people that I get to meet. Everybody's super excited for everybody else to achieve the same dreams, and we all really hope that we can see each other one day on a space mission. That's a crazy dream, but with so many people, with over 1,000 members, I think it's definitely possible that some people in our organization would get to go to space together, and hopefully it'll be even more than that someday. We have members from all over the world now, from every continent except Antarctica. Well, one of our members has actually been there. From over 50 countries, many languages, just all over the world in general. And it's just amazing to me to see the number of people who come in of all ages and are just like, I want to go to space. Here are some people who also want to go to space. Let's work on this together. I think that kind of collaboration is exactly what the future of the space industry needs and will keep us pushing forwards, on and on, upwards to the stars. Now Pedro is going to talk a little bit about international relations in space and how IOAA plays into that.
Thanks, Katie. Hello, everyone. My name is João Pedro. I'm from Rio de Janeiro, Brazil. I'm co-founder of the International Organization of Aspiring Astronauts, and I'm here to talk about a very important subject that was even one of the reasons we founded IOAA. The subject is the importance of international relations for the future of space exploration. So, I'm not an international relations student. I actually studied mechanical engineering, but I left because I decided to study computer science, since one day I intend to become a software engineer. Although I love computer science, I'm also very interested in other subjects, and one of them is international relations. I love connecting with people from completely different cultures than mine, because I think that a peaceful exchange has only good things to add, and this is what I'm going to talk about today. The importance of a good relationship between nations in the new age of exploration is undeniable. The space environment is so complicated and so challenging that it forces us to combine technology coming from different cultures around the planet. But before I go deeper into this subject, I would like to tell you a little bit about our past, because reflecting on the actions of humanity is essential to understand the importance of an international collaboration. The feeling that guides us into space is the same that made the explorers of the past cross the oceans to reach new lands, but our mentality needs to be different. At that time, the world was divided and everything was about finding new trade routes, which eventually leads to the colonization of a newly discovered place. The ships of each nation, even the most expensive ones, provided a decadent condition for the well-being of each crew member, and as a consequence, many died on the voyages. Nowadays, we have a wide knowledge of how each population organizing themselves for these navigations and the technology that each one had to evolve their ships. And this is where we need to pay attention. When we analyze the techniques that each culture had for traveling, we can realize that problems found in one were not a problem in the other. To give a better example, a Chinese ship had solved problems that a Spanish ship had not found a solution or didn't have the necessary skill to solve it. Now imagine if all the nations that explored the oceans looking for new roads at that time had joined together to create the most advanced means of transportation and solve the problems of the tracking devices. Our history would surely have been different. This new ship would have been more comfortable, and the technology used for tracking would have advanced to the point where we could discover much of the planet in at least a century. Although this is a utopian vision, it would be possible if we had changed our behavior. Back to the present, it's important to have the same line of thought when talking about space exploration. Basically, the importance of a good relationship with other nations for our future history in space, it's because different cultures provide different worldviews, and as a consequence, these views give us different ways of solving a problem. If we work together and focus on one goal, we have the ability to establish a human presence on Mars faster than we imagine. And I'm sure that when we have a manned mission out of our solar system, we will have a ship filled with different flags. Because when we do such a mission, it will be the result of a collaboration involving many different nations. We are all the same species. We all have the ability to learn and conquer anything when we have the opportunity. And the only difference between you and me is that I was born in a different part of the planet Earth. But what matters is that this planet belongs to all of us. We need to take care of it, but at the same time work together to seek our next home in the stars. So now I would like to show you a video of when I attended a talk by astronaut Mulry. She is a veteran of 3 missions to space and became the second woman to command the space shuttle. In this talk, we had the opportunity to ask her a question, and I decided to ask her if international relations will grow in the future of space exploration. That was her answer.
João Pedro Cosso from Brazil. So when you talk about the interesting international relationship between you and your crewmates, it made me think about the relationships between nations in the future of space exploration. Do you think that when we have our base well-defined on the moon and are going to Mars, the international collaborations will increase? I dream of one day being an astronaut, and I even have an international organization focused on that. That is amazing. That's fantastic. Thanks for asking that question. I hoped that everyone would get that message from what I was saying. Yes, and in fact, a new country, Australia, was not a part of the International Space Station, but they've already been one of the first to sign up for the Moon to Mars program. So I expect that we will have all the same partners we had on the International Space Station and many, many more. One of the profound effects that can happen when you pool your money and resources is that then everyone gets access to the science and also to the inspiration that occurs when you send astronauts into space. Many countries do not have their own rockets capable of carrying people into space, but they have been able to send people from their country into space the first time because of the joint collaboration. So as we think in the future about the science, and as we go forward, we really have to do it this way. No one country should actually dominate as we go out into the solar system. We should be working together to make sure that we are exploring safely and sustainably. And if we are leaving people to colonize places, we have to be working together on that. We can't just let one country decide make all those decisions.
The answer was amazing, wasn't it? I felt inspired when I was at the lecture, and I hope you did too. Okay, now I will announce with Prafamesh Parapatre the newest project that IOAA will launch in 2021. Prafamesh, go ahead.
Thank you, Joe. I'm sure everyone will enjoy this. Myself, Pratham Parapatri, Secretary of National Space Society, US Mumbai, and Administrator for Robotics Team at IOAA, International Organization of Aspiring Astronauts. To begin with, I would like to discuss the importance of robotics in space. Well, sending a robot is much cheaper than sending a human for a deep space mission, as well as it doesn't concerns for safety of the human that we are going to send for the deep space missions, as well as no waste will be generated, and robots can actually sustain the harsh environment of space without having any trouble to deal with, getting into spacesuit and performing the extravehicular activity. And we don't have to actually bring them back to the Earth or for analyzing samples, as they actually have a small science laboratory about them with some instruments that can be used to analyze the samples or particular rocks on that planet or on the moon itself. And they can easily perform riskier or impossible tasks, which are kind of risky for humans to perform while they are on other planet or on the moon or into deep space mission. Because in deep space mission, communication is a thing that is supposed to that is very essential for astronauts to have. And as we are away from each other, it takes time for information to travel from Earth to Mars or even further. So sending out humans for deep space mission at initial stage isn't something that we should do, but robotics is one of the alternative to that. Moving on to the next slide, we can see the advancement of robotics, right from setting an robotic arm on the International Space Station to sending Perseverance rover and building a humanoid robot called Valkyrie that is in development by NASA, as well as other space agencies, so that before sending humans to Mars, we can actually send humanoid robots who can actually build the habitat for upcoming astronauts on the Mars. Again, these are just a hint, a glimpse of how the space robotics has grown over the period of time, right from the Apollo mission to today's Perseverance missions to Mars.
The reason why Prof. Mesh gave this amazing presentation is because we are going to start a science team, the IOAA robotics team. The team will be separated into high school students and undergraduate students, and both levels will have several extracurricular opportunities that will help you on your journey to become an astronaut.
Well, what we are going to do while we be functioning online, we will try to network as much as possible. We will try to cover up the basics of what is needed to develop a robot or even a rover, or in fact a humanoid rover too, as networking is the key to move ahead and make our organization grow, as well as we will try to get sponsors and make our base perfect and participate in various hackathons designed by different organizations or different societies, or in fact by different space agencies. And if we can get some space agencies in collaboration with us, it will be a great help for us. Over to you, João. Thank you so much.
We have several plans for the future of the robotics team. Basically, after the online studies and preparations, we have the goal of taking the whole team to participate in some face-to-face competition. We will even start our study focused on some specific competition, such as the European Rover Challenge, the Indian Rover Challenge, the Artemis Student Challenge, Mars Rover Competition, Google Lunar X Prize Competition, and the University Rover Challenge. So, the admission process for our team will have 3 stages. In the first step, you will need to fill out a form requesting specific information about your knowledge in the field of robotics. Then, we will give you a skill test in the area you want to study on the team. And finally, we will do an interview with you with 15 questions. 5 about specific situations we can go through, 5 about the skills you will perform, and 5 about your personal philosophy about the future and the team. We will start the IOAA robotics team in the process in May. We don't have a definite day yet, but it's confirmed that we will start this project in May 2021. To end this topic, I would like to thank Space Magica for hosting this event with us, and I would also like to thank you for attending our conference. We at IOAA and Space Magica are proud to have brought together such amazing people who are dedicated to achieving the same dream. A dream that we will all achieve one day, to reach space as an astronaut.
Hello citizens of the universe, welcome to the Space Magica and IOAA Aspiring Astronaut Conference. This conference is like an amazing story. The knowledge and guidance we will get from this conference about astronomy, science, technology, rockets, rovers and landers are the main chapters of this story. It is a pleasure to read a story when the writer writing it is a skilled expert in his work. In this case, the speakers of this conference are the true author of this conference story. Next 5 days, we will get valuable guidance from all of them. Their brief introduction and conference schedule are as follow. Welcome again future Martians. I am Pravin, award-winning scientist, founder, member and CEO of Space Magica. My topic for this conference is the introduction of Space Magica. Already you know in one line that the Space Magica is an aspiring astronaut training center and visiting center. But from Space Magica, it has never been told what training will be done, who will get it and where it will be done. Today, for the first time in the history of Space Magica, I will answer this question. Where is Space Magica located and what is the final cause of making it? After food, water, air and shelter, education, research and tourism are the three important things of human life. People get an education so that they can become doctors, engineers and earn a good salary. Talking about tourism in a simple language, people from all over the world go from one country to another or from one place to another in a pursuit of recreation, relaxation and enjoyment. It's called tourism. but things will change in the coming times. People who enjoy tourism on Earth today, in the future will go to the moon, in space, on Mars for enjoyment. It will be called space tourism. Those who study today to become doctor, engineer, in future will study to become astronaut or to get space related jobs. This will be called astronaut training or space education. The interesting fact is that the space related jobs on Earth will increase by the more than 15% after human beings take the first step on Mars. We surveyed according to which 95% of the people wanted to go on the moon, on Mars or in space, and 82% of people wanted to take astronaut or related training. But both of these things have a problem. Dennis Tito, an American engineer and entrepreneur who is considered the first space tourist on Earth, went to the International Space Station in 2001. He had paid $20 million for this 8-day space trip. Space Adventure Company is charging $150 million per seat for the moon's flyby mission. People who have diabetes, blood pressure or any other disease, children, aged people cannot go to the moon and Mars as a tourist. Also, there is no guarantee of life in this journey. We know that 14 astronauts were killed in a space shuttle accident. If we think of astronaut training, then it is not given to school or college students. Some institutes offer astronaut training education, but economically poor middle class students from Asia, Africa and around the world cannot afford it. All these problems mean that the era of space education, space tourism is coming to our doors. But this is like everyone wants to buy a super luxury car, but not everyone can buy it. But don't worry, the answer we got for all these problems is named Space Magica. In Space Magica, students will get space education, astronaut training at an affordable cost, and private audience can enjoy the moon, Mars and space travel. Now you can see micro part of the Space Magica's plan. We have divided the Space Magica into a few bases and parts. This part called Astronomy Gallery. Students and visitors will see the models of stars, galaxy, rockets here, and students will study the universe from the Big Bang to Big Crunch and other things like rocketry, stargazing and more things. We get to learn history in school and college, but in Space Magica we designed a course in which students will study the future. For example, topics like how our world, human life will be in the future. This is a moon base where students will be trained to live and survive on the moon, collecting and testing the soil and stone samples of the moon, learning the Eagle Lander's landing on the moon with the help of simulation. The students will be able to do many such activities here at the lunar base. This Mars based training will be similar to the moon base. You will be able to see some additional things on Mars base, like you can see the blue sunset of Mars, Olympus Mons, which is the tallest mountain, and Valles Marineris, which is the longest valley of Mars. In the coming times, the humans will settle the colony in the clouds of the planet Venus. The houses of that colony will be big balloons in which farming will be done. You can experience this amazing balloon here. Maybe you all are aware of underwater training, spacewalk training, space capsule docking and undocking, mission control room. Training of all these things will be given in Space Magica Center. I and Space Magica team have done a lot of research on this, and because of that you will actually be able to practice docking and undocking capsules the same way you see in the video. Last but not least, the arrangement of accommodation and food will be the same as space life. This was a brief introduction of Space Magica. This is only 10 to 50% of total plan of Space Magica. Due to Space Magica's secret policies, I cannot tell you Space Magica's complete plan, but I hope you like this plan of Space Magica. Who can take training in Space Magica or who can visit? We work in Space Magica with thousands of year-old Indian moral thought, Vasudhaiva Kutumbakam, which means that the world is one family. Space Magica is always open for everyone, from first grade students to 100+ old age person. It doesn't matter to us which country, religion, country, gender, time, universe, the background you belong to. Even if you are an alien or time traveler, we gladly welcome to you here. The centers of Space Magica will not be built in just one place or one country. We have a dream before the end of this decade to make 10,000 centers of Space Magica around the world. Talking about today's condition, we are expecting the first center of Space Magica will start at the end of this year in December 2021 in Pune, which is an IT hub and education hub and a beautiful city of India. You can apply for membership by visiting Space Magica's website. Our membership is free for all. In 2020, we organized the Space Quiz World Cup. A lot of organizations organized quizzes. but we are probably the only one to organize in the World Cup format. On 28 June 2009, great scientist Stephen Hawking threw a party for time travelers. We repeated this experiment in 2020. We also got the results of this experiment just like Sir Stephen Hawking. Perhaps we are the only organization that has a parliament. Some times ago, our parliament election were held. Now the great space leaders elected by you are working to advance the Space Magica. Space Classroom is available on Space Magica's website. You can read articles and watch videos related to science, astronomy, technology here. If you are writer or content creator, you can send your work to Space Classroom. Very soon, we are going to provide courses related to space career, astronomy, space technology in Space Classroom. I am grateful to IOAA and Infinoscope for collaborating with us. Like Space Magica, IOAA is a great platform for aspiring astronauts. João and Katie have a major contribution to successful organization of this conference. I wish them success. Some days ago, Infinoscope founder Pravin said a very good thing, that people cannot buy science magazine because magazines are expensive, and that is why she created a venture, Infinoscope. That's a great thought. All space lovers should read Infinoscope. The founding members of IOAA have presented collaboration topic very beautifully, so there is nothing left to say about it. So this is the end of the topic, the Space Magica introduction. Before the end of this short session, many students ask me what to do to become an astronaut. I will answer that question. A career in space is a big topic to discuss. On this, we will have a separate session soon. Becoming an astronaut doesn't just happen overnight. It takes many years of education and experience to meet the basic qualification. First, decide why you want to become an astronaut. It is very important to get an answer to this question, because many students do not move towards fulfilling their dreams when they get failed on the first attempt. It is most important that you should be a citizen of the right country. For example, citizens of India cannot apply to become astronaut in NASA. Possess a master's degree in STEAM field. STEAM stands for science, technology, engineering and mathematics. Many students feel that engineering is necessary to become an astronaut. Understand that even those who do a career in biology can become astronauts. Have at least 2 years of related professional experience obtained after degree completion, or at least 1000 hour pilot in command time on jet aircraft. To become an astronaut, you must be mentally healthy. In this world, 2% of smart people think that the earth is flat. If you too are on the list of the smart people, then check your mental health. Your eye vision, either naturally or with corrective lens, should 20 feet, and blood pressure not more than 140/90 in sitting position. Required height for astronaut between 62 and 75 inches. That's all from my side today. I am thankful to all team members of Space Magica, and especially João and Katie, the pillars of IOA as well as the pillars of this conference. Big sci-fi thank you. Lift off.
everyone. It's a great honor for me to take part in the first space conference organized by the International Organization of Aspiring Astronauts. In the next couple of minutes, I would like to share my journey to space camp. First of all, I would like to introduce myself. I'm Sandali Kumarasinghe from Sri Lanka, and I'm currently doing my undergrad studies in aerospace engineering. I was 18 when I went to the space camp. I always wanted to work in the space industry, but I never dreamed of becoming an astronaut or going to space before going to the space camp. So space camp holds a special place in my heart because now my ultimate goal is to reach space one day. So that's my story. Before starting the presentation, I would like you to watch this small video clip on space camp.
For more than 30 years, Space Camp has mined, captured, and released the potential of young people from around the globe. Students and educators from more than 60 countries have attended programs at the U.S. Space and Rocket Center in Huntsville, Alabama, home base for Space Camp, an official NASA visitor center, Smithsonian affiliate, and host to one of the world's largest collections of space history and artifacts. The Space and Rocket Center is a unique environment suited to launch life-changing learning. Here, those attending Space Camp Robotics, and Aviation Challenge discover potential that traverses from what if to can do. Beginning with orientation, Space Camp trainees meet their teammates and are immersed in their mission, principles of leadership, and decision-making that are inherent to achieving mission objectives. In addition to the surrounding environment of the Space and Rocket Center, this immersive experience requires special camp facilities designed to accommodate high standards for the health and security of camp trainees. Security and medical personnel provide round-the-clock services. The dining hall, or crew galley, meets dietary needs and addresses dietary restrictions to ensure that each trainee has a positive experience. Camp counselors, called crew trainers, are available at all times. Many of these men and women are university students or recent graduates who aspire to work in science and high technology fields. Crew trainers undergo extensive instruction spanning the operation of Space Camp's astronaut training simulators to daily contingency and emergency procedure. Trainees have diverse backgrounds and interests, and that means communication and problem-solving skills are sharpened throughout multiple-day resident camp experiences. Astronaut training exercises patterned after actual simulations used in manned spaceflight programs inspire dreams of what's next in pushing the space frontier. Space Camp's unique simulators, such as the 5 Degrees of Freedom, Multi-Axis, and 1/6 Gravity Chair, are integral to each team's mission and help launch trainees to space station and sharp realizations of requirements of life beyond Earth's atmosphere. Advanced programs incorporate microgravity exercises in the underwater astronaut trainer. The buoyancy of water invokes a sense of weightlessness, as well as offers the challenge of manipulating tools and equipment while wearing life-protecting suits. Interactions between land-based work and space-side personnel determine mission success or failure. Aviation Challenge finds trainees in land-based fighter pilot simulations. The Centrifuge is among unique simulators for this program. Its use to prepare pilots has a long history, and trainees will experience up to 3 Gs, or 3 times the force of Earth's gravity. Water survival training is part of both Aviation Challenge and Space Camp. Water, land, and sky provide the environments for Space Camp Robotics, where trainees learn and apply principles in robotics design and engineering. All trainees build expectations while building new understanding of teamwork and leadership. Space Camp, Aviation Challenge, Space Camp Robotics, releasing potential, fueling the future.
Space Camp. Space Camp is a 6-day program conducted by the US Space and Rocket Center and train us to become astronauts without even going to space. Space Camp was first launched in 1982 for the young people of United States, but currently trainees from all across the world travel each year to the US Space and Rocket Center to engage in the space-related programs. Trainees get to learn about space, the flight history, and work together in teams, and also they get to engage in simulated space missions. This is the summary of things that I got to do at Space Camp. So, like I mentioned, we get to do simulated space missions. There were 3 missions which I got to do during the space camp. Talking about it, first there were 3 missions, 1-hour missions in low Earth orbit, and 3-hour mission, or the extended duration mission, and the Orion Mars mission. So if I talk about the first mission, the 1-hour mission in low Earth orbit, so I hope you can see a picture. So this is like with this is a simulated environment where you feel like you're actually in space, and you actually you are in the mission control. So during the 1-hour mission, I got to do an EVA. EVA is an extravehicular activity which is performed outside the capsule or the shuttle or your spacecraft by an astronaut or a cosmonaut. So I have a small video clip which would help you to imagine how it's likely to be do an EVA in space. So actually this is a footage from a space related movie. So this is me doing the EVA during the 1-hour mission. So basically there were 2 astronauts during our mission during the EVA, where there were 2 mission specialists. So we had to fix 2 antennas of a satellite. So in this picture, the gold plated, I hope you can see a gold plated area. So we were like in this area doing the EVA. So in the 3-hour mission, or the extended duration mission, I was the ECOM and the CMO. So ECOM is Emergency Environmental and Consumables Operations Manager, who monitors environmental systems on board the orbiter, including cabin pressure, temperature, and take care of the emergency situation. As well, like I mentioned, I was the chief medical officer. CMO is the person who take care of the health and safety of the crew and the members, and he or she should take care of all the anomalies that is taken place in the space, or it can be even in the mission control. So during my mission, these are some of the pictures of in the first picture, I am at the mission control. So I am giving, and I'm giving the navigations and the instructions whenever they have an anomaly. These are some of the pictures where actually astronauts got sick during the space mission. So I have to mention that it's likely not it's not likely to happen this in space, but during since it was a simulated mission, we were preparing how to act in such emergency situation. So during the Orion Mars mission, I was the flight activities officer. I was responsible for providing providing guidance, navigation, and so, for example, we were landing this space probe in a site of Mars. So I was giving navigations to land in a site where there was good environment conditions. So in this picture you can see that's the place where we did the Orion Mars mission. Here comes my favorite part, simulators, because actually it's really funny, and it's really you know, after doing really tough stuff, you're getting to do simulations. So the first simulation was 1/6 gravity chair. So during the missions, astronauts are trained to adapt to the gravity in planets like in another planet, especially moon is not a planet, but when astronauts went to the moon, they have to adapt to the gravity. So to adapt, the astronauts are being trained here on Earth. So this is me. So this is a small video where an astronaut actually you know, jumping on the surface of the moon.
Both at the surface at Taurus Littrow, we'd like to dedicate the first steps of Apollo 17 to all those who made it possible.
This is me on the 1/6 gravity chair, which all I had to do was hop like a rabbit. So yeah, the next simulation was multi-axis trainer. So there can be disorientation during the re-entry. So sometimes there will be like spins, so the astronauts could get sick. So that's the reason why they are being trained to endure such a situation. So this is me at space camp doing my multi-axis trainer simulation. So in this picture you can see a pool. So actually this is our diving site. Unfortunately we couldn't do the underwater astronaut training session, which is helping you to understand what it's like to be in microgravity. So unfortunately there was a thunderstorm and we couldn't perform this task. Engineering challenges: constructing a rocket, designing a spacesuit, and thermal protection. In the first activity we designed a rocket using the necessary components, like considering the factors like center of gravity and choosing the perfect nozzle for the rocket, and in order to have a perfect launch for the rocket. But unfortunately we couldn't launch the rocket due to the bad weather. And the next challenge was designing a spacesuit. Sports, which is space debris, pressure, and oxygen, radiation, and temperature are the factors which affect astronauts in space. So we had to consider those factors and we had to design a spacesuit. We were not using actual materials, but we just have to you know, take the context of these 5 factors and design a spacesuit. In the next activity it was thermal protection, where we to design a suitable material which would provide protection during excessive heat for an astronaut during a space mission. Other than that, there were many fun activities and several lectures on space law, gravitational waves, career guidance, and museum tours as well, where we got to learn about the Mercury, Gemini, and Apollo missions, and almost the history of space exploration of US, and it was very informative. The most important day of the whole week is the graduation ceremony, and this is the moment we all have been looking for. So there were hundreds of other students who got their wings on this special day. So I got my wings from the NASA astronaut Larry DeLucas. It was such an amazing day, and it is such a memorable moment for me. After the graduation ceremony, I got the chance to take part in the event called Lunch with an Astronaut. So I got the chance to have lunch with astronaut Larry DeLucas and to ask questions from him. And this is me and astronaut Larry DeLucas. That was the first time that I got to meet a real astronaut, and I got a few autographs as well, which was really amazing and really special for me. So thank you so much, guys, for joining for this session, and I would like to thank International Organization of Aspiring Astronauts for inviting me for this event. It's a great honor as well as a pleasure for me to talk to a couple of people who share the same dream, and it feels amazing. So I would like to say that keep working on your dreams very hard, and someday you will get to reach for your dreams. So keep working hard and reach for the stars.
Theorizing gravity and black holes. Hello, my name is Sophia Knowles, and I'm a 14-year-old GCSE student. I'm a space enthusiast and a member of the IOAA community. I hope to be able to research and study astrophysics and cosmology at a higher level in the future. Sources for this presentation are listed in the final slide. I'm passionate about this subject, and I really hope that you enjoy it and even learn something today. Isaac Newton. So I'm pretty sure we've all learned about Isaac Newton at one point, and he contributed greatly to physics, but it's also important to mention that before Newton, much of the foundations of Newton's laws of motion were based on Galileo's measurements and experiments. In 1687, Isaac Newton revolutionized physics when he published Principia Mathematica. In it, he provided a model for how gravity works. It's important to note that he did not state what gravity is. So Newton's first law of motion. Objects in motion will continue to move in a straight line, and objects at rest will remain at rest unless acted upon by an external force. A good example of this is when in sci-fi movies, say, two astronauts are being set off into space and they're traveling to Mars. They end up shutting off the engines once they are on course. This is because they will continue to move forward to Mars because there is no external force changing their path. And the only times they'll need to turn on their engines again would be to adjust the course or to land. So Newton's second law of motion is that net force is equal to mass times acceleration. This means that the velocity of an object changes when it experiences an external force. The more mass an object has, the higher the inertia. For example, a bowling ball would have more inertia than a volleyball because it has more mass. So it would require more external force to change its motion or state of rest. This describes how the acceleration of an object is equal to the force you apply to it divided by the mass. This means that things fall at the same rate in a gravitational field, since when you calculate the acceleration, the force and mass cancel each other out. Common sense, however, would tell you that a feather would fall slower than a hammer, but this is because of air resistance. In a vacuum, however, they would fall at the same rate because there is no air resistance. And we see this exact experiment being taken out on the moon, where an astronaut drops a hammer and a feather, and they do indeed fall at the same rate. Newton's third law of motion states that every action has an equal and opposite reaction. So Newton's law of universal gravitation. The gravitational force between two objects is proportional to the product of their masses and inversely proportional to the square of their distance apart. 50 years before this discovery, the astronomers Johannes Kepler came up with 3 laws that described the way orbits worked. We know that these laws were accurate because it matched what astronomers saw in the sky. Newton's law of gravitation was accurate to Kepler's laws, and combined with previous laws of motion and calculus, was able to prove them. So we see here that force equals gravity multiplied by the mass of one object times by the mass of the second objects divided by the distance between the center of those two objects squared. However, there was a problem. Due to Mercury's proximity to the Sun, it's difficult to see its transits. Transits being when a planet passes over its host star. However, when the planets would align in a certain way, scientists would gather to witness Mercury's transits. In order to predict when Mercury would pass the Sun, they would use Newton's law of gravitation. However, there was a problem. Mercury wouldn't appear on cue. This concerned scientists deeply, so they went searching for an answer to Mercury's lateness. They tried to explain this anomaly by suggesting that there was a planet that they hadn't discovered yet, which was messing with the orbits due to its gravity. They even said that the reason why they hadn't found it yet was because it was blocked out by the solar glare of the Sun. They named this ghost-like planet Vulcan, but they couldn't find it simply because it didn't exist. Now that's where Einstein comes in. Albert Einstein, born in 1879 and died in 1955. Einstein was a theoretical physicist known for his development of the theory of relativity. It completely changed the way we viewed gravity, time, and the universe itself. But he had also a strong connection to politics. He was involved in anti-war demonstrations during the First World War. He was an advocate for civil disobedience. He warned of the dangers of nuclear war when there was a rise in anti-Semitism. Despite rejecting the idea of a biblical God, it led him to identify with the Jewish community since he was of Jewish descent. Einstein's efforts towards peace achieved little and certainly didn't achieve him much popularity, but he was offered the presidency of Israel due to his support of the Zionist cause. But he declined, saying that he was too naive for politics. But perhaps it's because, as he said, equations are more important to me because politics is for the present, but an equation lasts for an eternity. Theory of general relativity. In Einstein's theory of general relativity, he states that that gravity is the effect of the curvature of space-time. Space-time is the fabric of the universe, where time is a fourth dimension. A good way to visualize this is to imagine a stretched out piece of fabric. That fabric is space-time. Now imagine if I place a bowling ball in the center, this for example would be the sun. It's a big and strong fabric. It will cause the fabric to dip and to curve. It will, then say we get some marbles and we set them in motion around the bowling ball, they will essentially start to orbit it. So when you are moving through a curved space-time, it appears that a force is acting upon you, which changes your path. Therefore, one of the first things Einstein did, using his geometric theory of gravity, was of course to calculate the straight line path of Mercury through a curved space-time. Fortunately, his calculations were exactly what had been observed on Mercury's transits. So why does everything fall at the same rate in a gravitational field? Because they are simply following the straight line path through a curved space-time. Another part of Einstein's theory is that energy is mass. We see this in his famous equation equals mc squared, which means energy is equal to mass times the speed of light squared. Therefore, light is the speed limit of the universe. You can't go faster than the speed of light. This is because if, for example, a spaceship tried to travel at the speed of light, as it approached the speed of light, its mass would become almost infinite. Time would nearly slow to a stop, and it would require an infinite amount of energy to push it to light speed. This is just impossible. To an observer, the spaceship would become increasingly squashed as its velocity came closer to the speed of light. This is not just an illusion in the frame of reference of the observer, but is exactly what is happening. Light always travels at 299,792,458 meters per second. However, its energy can change. For example, light would get shifted to the blue end of the spectrum as it gains energy and become shifted to the red end of the spectrum when it loses energy. That's because the more energy, the higher the frequency, therefore the more blue. The less energy, the lower the frequency, therefore more red. We know that light has no mass, so in Newton's theory, light shouldn't be affected by gravity, whereas in Einstein's theory, we know that light is affected by gravity. This is because it doesn't matter that light has no mass. It is following its path through a curved space-time. So, if an object has enough mass and curved space-time so much, it can cause light to bend around the object. This is known as gravitational lensing. It's important to remember that time is a fourth dimension, so when an object is heavy enough, it can warp space-time so much that it slows down time. This is known as time dilation. The twin paradox is a popular theme in sci-fi movies like Interstellar. But what is it? So, say we have two newborn twins. One is earthbound, let's call her Eve, and the other is sent to space traveling at a velocity of 80% the speed of light. Let's call her Lucy. When Lucy returns from her 8 light-year journey, it's Eve's 10th birthday. However, for Lucy, time has been ticking more slowly since she has been in a moving time frame. So by the time she comes back to Earth, it's only her 6th birthday. Eve, her twin, is now 4 years older than her. The universe is insane. From Lucy's perspective, she has been at a state of rest, and Eve is the one moving away from her. This paradox is solved by the fact that only Lucy has undergone acceleration. Lucy has been in 2 different time references, on the way into space and on the way back, whereas Eve has only been in one because she stayed on Earth. So, what is the evidence for general relativity? Initially, general relativity caused lots of controversy in the scientific community until, in 1919, Arthur Eddington provided the evidence needed to prove general relativity. Eddington traveled to the Atlantic of Principe to witness a solar eclipse and to observe the stars behind the sun. He photographed the stars that could now be seen due to the lack of solar glare. In the photograph, it showed that the positions of the stars had indeed been shifted due to gravitational lensing. To truly see the effects of general relativity at an extreme level, we need to see the most extreme thing known so far in the observed universe: black holes. So how do black holes form? Stars are fueled by something called nuclear fusion. Nuclear fusion is a process when hydrogen and helium nuclei are smashed together at high speeds and pressures. When hydrogen and helium runs out, the star will begin to die. The outcome of its death depends on how massive the star is. If the star is relatively small or average size like our sun, so about 109 Earths across its face, and its diameter being 1.392 million kilometers with a circumference of 4,366,813 kilometers. At its main sequence, when its nuclear stores run out, it expands and becomes a red giant. It then shrinks into a white dwarf, then decays into a black dwarf. If a star is between 1.4 and 2.8 times the mass of the sun, it's in its main sequence, it becomes a red supergiant star, then a supernova, then a neutron star. A neutron star has collapsed under its gravity to such an extent it consists almost entirely out of neutrons and it's extremely dense. If the star is more than 2.8 times the mass of the sun, it will follow a similar route as to the neutron star, but instead will collapse into a black hole. This gravitational collapse happens because the mass of the star has been compressed into a volume called the Schwarzschild radius. I apologize for my pronunciation. What is the Schwarzschild radius? The Schwarzschild radius is the radius at which space-time surrounding a spherical mass becomes so curved it wraps around and encloses it. The Schwarzschild radius for the sun would be 3 kilometers, and for the Earth, it would be 1 centimeter. So, to make the sun become a black hole, you would need to compress all of its mass into only 3 kilometers, and for the Earth, only 1 centimeter. However, it would be impossible to do that since there wouldn't be enough mass to allow for it. So a black hole is the most extreme object known to the universe. Nothing can escape it, not even light, the fastest thing in the universe. Due to the extreme mass of black holes, they warp space-time so much that time dilates to an extreme amount and light bends around it. Black holes are monsters that will suck up anything that gets too close. In a black hole, there is something called the event horizon. The event horizon is the point of no return. When something gets to the event horizon, it is impossible to escape. Nothing can overcome the gravitational pull. At the center of the black hole, there is a point of infinite density, yet infinite small size. According to general relativity, this is known as the singularity. We don't exactly know what a singularity is yet, but it's like trying to divide something by zero. So what if I pushed you into a black hole? So imagine we are two astronauts traveling near a black hole. We decided to both go out on a spacewalk. However, I am annoyed at you because you decided to eat the last Oreo. So logically, I decide to push you into the black hole. For fun, I decide to observe you falling into the black hole. I would see you fall into it slower and slower until you freeze. This is because black holes distort space-time so much, time slows at the event horizon. Due to the sheer amount of gravity acting upon the light you emit, the light becomes dimmer and redder due to losing its energy. So you would appear to become dimmer and redder until you just disappear. I would never see you fall in, simply because that light could never get to me, because even light can't escape a black hole. But from your perspective, you would fall into the black hole faster and faster. The light around you would be shifted due to the blue end of the spectrum because it's gaining energy. More gravity would be acting on your feet, which would stretch your body. This is known as spaghettification. I'm not kidding, scientists actually refer to it as spaghettification, because you are quite literally being stretched like a spaghetti string. You would become heavier and heavier. Then you'll be ripped apart atom by atom and die a very painful death. How lovely. So what is inside of a black hole? The short answer, we don't know. But there are many theories as to what could be on the inside of a black hole. Some people speculate, such as Stephen Hawking himself, that black holes could be a door to another universe. We know that there is a singularity located at the center of the black hole. Classical physics tells us that this is an infinite point of smallness and density, whereas quantum theory says that it is an extremely dense and small point, but it is not infinitely small and dense. As of right now, there is no way to know what is on the inside of a black hole, but there are some theories that are worthy contenders to find a solution to the problem. Hopefully, one day we will discover the answer to this. So, how do we even know that black holes exist if the light from a black hole can't even get to us? Well, in 2019, scientists across the world worked together to find a photo of a black hole. They worked on massive telescopes that collectively would add up to a huge telescope the size of the Earth itself. Luckily, when the photo was taken, the black hole was eating some light. So it bent around the black hole, thus illuminating it, so it allowed astronomers to take a photo of it. But before they took a photo of the black hole, how were they even sure they existed? When matter is dragged into a black hole, it will be heated up so much as it is ripped apart by gravitational forces, it would release X-rays into space. Scientists searched for these X-ray signals and found a strong source in the Milky Way near a constellation called Cygnus. The orbit of this object, named Cygnus X1, was too massive to be a neutron star and was in fact a black hole. Black holes were no longer a theoretical entity. In fact, there is a supermassive black hole in the center of our galaxy. It is likely that it is common for galaxies to have black holes in the center of them, especially in spiral galaxies. But don't worry, we are safe. This black hole won't suck us into its gravity anytime soon. So can black holes die? If so, how, and how long would it take? That's when we meet Stephen Hawking. Stephen Hawking, born in 1942 and died in 2018. Stephen Hawking was a theoretical physicist and cosmologist. He was diagnosed with motor neuron disease, ALS, and he was given less than 2 years to live. The motor neuron disease slowly paralyzed him over the decades and meant that he had to use a speech-generating device to communicate. He greatly contributed to science, especially in the area of black holes, and sought for a unified theory of general relativity and quantum mechanics. It used to be thought that a black hole would never die until Stephen Hawking produced Hawking radiation. He said that black holes aren't completely black since they emit radiation. Quantum theory predicts that throughout space, pairs of virtual particles and their antiparticle appear to annihilate each other. Some of these antiparticle pairs will appear outside the event horizon of a black hole. It is possible that one of these particles will escape while the other falls into the black hole. To preserve the same amount of energy in the system, the particle that fell in must have negative energy. This would cause the black hole to slowly lose energy and mass. This is known as black hole evaporation. However, Hawking radiation is only a theoretical prediction. If it is correct, it would mean black holes do in fact die, but it would take up to a Google of years, which is a very long time, and we certainly won't be around to see it. In conclusion, we have learnt about Newton's theory of gravity, general relativity, and black holes. However, all of what I have touched upon today barely scratches the surface, so I hope it inspires you to learn more about it. I hope you have enjoyed today's presentation and that you have a nice day. And here is a list of the following resources used to make this presentation. Thank you for listening.